Hey guys, welcome. Where are we on Friday? We are almost at lunchtime. So we are desperately close to this time. Hands up who's coming to PubConf today. Yes. Give yourselves a round of applause. It's a fantastic event. We've got these cool T-shirts that you're going to be seeing people wearing. It's going to be a lot of fun. If you don't have a ticket yet, about 1 hour ago, there were 6 tickets left. So if you're still interested, I can't remember which pub it's at, but it's somewhere nearby. 6 tickets. Get on that now if you want to be coming. So we have got a lot of content to cover today. So I'm just going to jump straight into things. From the looks of this picture, you can guess what I like. And that's beer. My name is Ben Who Likes Beer on Twitter, and you can find it everywhere else like that. I run a company called Pinch, which is the shirt I'm wearing. Little startup out of Brizzy. If you're interested in payments, if you've heard of Stripe, if you've heard of PayPal, any of these kind of things, hit me up because we're young, we're early, we're hungry, and we're keen to solve a bunch of problems. So let me know about that. So speaking of which, the thing we're doing today is talking about identity server and building APIs for developers. So that you know you're in the right room, what we're going to be covering is basically some API design. So we're going to walk through what I consider to be good design, just so we can see what I've got going on. And then the second half of this is going to be adding identity server to protect everything. Okay? And I'm going to show you a fairly real world, in fact, a very, very real world application here. Okay? This is my actual production code. It's what's shipped right now. I'm on the master branch. You are looking at what is in prod. And therefore, if you see maybe a key here or there, if you see a secret, if you see something that's not right, be quiet about that. Come tell me afterwards. But basically, I also want to start this talk with some incredible news. Because I don't know who was in Barry Doran's talk on ASP.NET Core, a few people, most of you. Then you already know that Identity Server is going to be integrated directly with ASP.NET Core in the future with 2.2 or somewhere just after that. And this is incredible news because not only is it going to make everything I show you today redundant, almost, no, I'm kidding. No, it makes it really simple. It's going to make it for the file new people who just want to get a project up and running. They're going to be able to make JWT tokens, and they're going to be able to, have proper authentication on their APIs right out of the box almost. It's going to be a few lines of code. So since we've got a lot to look at today, what I'm covering is what you can do right now. It's what's in production, and it's a more complex, I would say, than normal implementation of an identity server in ASP.NET Core. So a quick, well, we're going to go look at the code. This whole thing's going to be codes. I have one slide after this. So a quick show of hands just to gauge people's knowledge. Who is currently using Identity Server 4 in a real product? OK, it's maybe a third, maybe a quarter to a third of the room. Who has dealt with any version of Identity Server or a token server of some kind? OK, we're looking at more of the room there. Beautiful. And who doesn't know anything about this and is just keen to find out what's going on? OK, a massive chunk of the audience as well. Perfect. All right, you're all going to get something out of this talk today because, again, I'm going to go through some what might be pretty easy and pretty basic things at the beginning. And then we're going to ramp up and add and add and add until we get to the final product. So having said that, let's escape out of there. Let's jump into Pinch, and let's just quickly, is this text size for the people at the back? Can you read that? You want a bit bigger? Yep, OK. I might have to do this a few times, but yeah, we'll do something like that. Yep, no worries, guys. Just give me a yell if I'm ever looking at something too small. So what we're going to do, and I do apologize, but the stuff on the right is going to be a bit small. We can zoom into it when we need to. So what we're doing is taking a look at my application. It's called Pinch. We've got it's an ASP.NET Core 2.0 at the moment version, running Identity Server 4 on the latest stable. And what we're going to look at first, and I'll make this a bit bigger too. What we're going to look at first is the portal, and I just want to give you an example of what we're going to do. It's a one request all the way through. And we'll get this up as well. What we're doing today, and let's just pick any old thing, payers, and I'll try and make this a bit bigger. Where's our response? OK, so what we've done is we've got a single-page application. It's an Angular app for anyone who's interested. I'm not really going to dive into client-side stuff today. OK, this is mainly focusing on the back end and the APIs. But if you have questions about that, I'm happy to take them at the end. And what we've done is we've loaded up a single-page app, we've authenticated ourselves, and we've hit an API endpoint, and we've retrieved some data, right? So far, so good. One thing that you should note is that the API that this single-page application is hitting is the very same API that I exposed to developers to build their products on. And this includes literally every endpoint, and I'll show you how you can lock down some of them towards the end. And it just makes it a lot easier because I've designed it API first. I built the API, then I built the thing that uses the API. And this is a really good way of building some of your own applications, if you're building greenfield things, at least anyway. And so what we're going to do first is take a look at the API design for how we went and fetched this data. And I'm also just going to flick between that and notes so I don't miss anything. But yeah, basically, we've just looked at one request, and that was just to prove that it actually does stuff. But where I want to start as well. Bear with me. Oh no, I hit yes. Oh well. Is it developers, guys? Developer. The place I want to start out is basically looking at the documentation, okay? And I want to describe how I've laid out the API and the reasons for doing so. Cool little tool, by the way. This documentation rendering thing. It's a product called readme.io. It can take in Swagger files, and it lets you add more documentation to that kind of stuff. So a little quick tidbit there. But the way I kind of outline my APIs, ignoring the authentication for now, is kind of with an entity. Okay, so if you've seen anything RESTful before, you'll know that you usually add an entity, and then you'll use your get and put and post and delete to go and access those things. But if you take a look at my API for things where it's not necessarily straightforward, payers is just API/payers. We can look at the top here, api.getpinch.com.au/test, so that you're hitting the test system, /payers. And everything from test before is like a base URL, and then payers onwards is our entity. So for getting a payer, straightforward. Get/ID, you'll get a payer. You want to list all the payers, it's just /payers. Saving a payer, it's a post to /payers. Deleting a payer, you can guess, is a delete to payers/ID. Now this is all very, that's basics, right? Where I like to get a little bit different is, for example, with functions that you want to perform on entities. So for example, here I've got payments that need to be executed in real time, so credit card payments. And so I go payments/real-time, and you'll make a post request to that endpoint. So I'm not afraid of tacking on function names to the ends of these URLs, because I think it's the easiest way to think about it when you think about what you're trying to achieve. So don't be so strict to be like, OK, well, I'm going to go /real-time payment/create. You don't have to think of it in a CRUD way. It works well for your basics, but don't be afraid to put on function names as well. And then for other things, I guess most of these are fairly straightforward. Gets. So it's all just entity-based and function name. And what we're going to do is we're going to dive into saving a payer, or a payment, I believe it was, actually. So let's quit yabbering, and let's take a look at our API project. OK, so one thing to note here, and I'll go over the solution structure in a minute as well. We're just in an ASP.NET Core MVC project, OK? And this is my API project. What I've got here is a payments controller, similar to other things you'll have seen. And again, we're just going to start easy and walk through what's happening. So what we'll do is we'll look at the post or the save method here. OK, so controllers, again, they should be relatively thin, very, oh, by the way, who here went to Jimmy's vertical slice architecture talk? OK, fantastic. That's a lot of the room. So what you'll see here is this isn't as articulately structured as his stuff. It follows it in the same vein, kind of accidentally. But a lot of the points I'll be making are roughly the same thing. And this is one implementation of a similar architecture that you'll see. And so, yeah, we want our controllers to be relatively thin. So what I've got here is the post endpoint. When using verbs, again, this is a more opinionated thing. I'm going to use get, I'm going to use post and delete. I don't like put. Instead, what I'll do is I'll have a post, and if you send me an ID, I'll update it. And if you don't send me an ID, I'll just create it. But what we have here is the payment save request. And this is a DTO or a class that outlines everything that you're expecting to receive. And similar to Jimmy's thing, this is like that request portion of the architecture. And we can have a look at this one here. And it's full of simple stuff, right? You've got the ID of the payment if you have one. You've got the payer ID, some amounts, some dates, and some other things. OK, very simple. We take that in from the body, and then we pass it immediately off to this line 96 here, a payment save options. Now, some of you will have used something like AutoMapper or something like that to do a lot of your left-rights. In this project, I've purposefully left everything very explicit, so you'll see a lot of left-right code in here. It's just to show off what's going on. And so we take in that payment save request model, and we pass it through to a payment save options model. And this is my kind of internal layer of DTOs. Okay? Wherever you see options, this is for the service layer to receive information. And the reason I don't share these two models together is because you can add some special information to your options layer that you really don't want from your request. And a couple of examples of this are the user ID, so who is making this request, and things like IP address and stuff like that. You don't want to ask that from your user. You just want to collect it and add it to that service layer. And you'll see here I'm passing in the sub-merchant ID, and we'll go take a look at how that's implemented a little later on when it makes more sense. But you can come in and take a look at your payment save options. And these are, again, very straightforward. It's just a DTO where we're adding things. But then what we're also doing is we're adding Fluent validation and our validation layer to the service layer DTOs. Okay? So what happens here is that I'm just asking for a few basic things. Who's using or has used Fluent validation before? Okay, most of the room, that's good. There's simple things like not empty, so it's required. You can make your own. I've got a has minimum payment amount. And some complex ones like make sure you don't give me anything that's not within the last 30 days. And so my validation, we'll just jump back now to the controller. My validation isn't performed until the service layer. So we'll get to that in a second. Moving down, still in our controller method here, I check if the response from the service layer was successful. And if it was, what we do is just double check again whether or not this is a new entity or an existing one by looking to see if we were passed an ID. If it is an update, we'll return OK 200. If it's a creation, we'll return created 201 using the created at root. And if we had a failure, we just post back the error messages that we got from the service layer. Okay, so the controller really doesn't do anything other than pass data through and then check if it worked and return the correct response. That's its responsibilities. And so yes, let's take a look at projections. So you'll notice with our response, I've got this thing here called from entity. So one thing that's really important is that you do not return your EF or your entity framework models back to the client, okay? They're going to serialize a bunch of properties that you do not want sent back. So similar to Jimmy's architecture again, we have this concept of the response DTO, or the response model. And in my case, I'm using this from entity. So response.data is as an EF model, and I'm passing it to the from entity. I'm just going to jump into this, and we'll take a look. We'll break it down in a second. So in my domain sort of project, my domain assembly with all my EF models and stuff like that, I also keep my DTOs in the domain layer as well. The response DTOs do a lot more transformation than the request ones. So you'll see some basic properties like ID, amount, and description, yada, yada, yada. Some things like I want dates to be returned in a specific way. So I'll map the data that's incoming to a private property, and then I'll expose a public property which has a response body that transforms that internal property there. So that's how I can control how things go back to the user on a per property basis. Another interesting one that I'm a bit opinionated about is how I deal with enums. When sending enums down to the client, so when you've got your API layer, anything you give to the customer that's an enum, I want it to be a human-friendly string, okay? Snake case, so it's got the dashes in it. And the way I achieve this is using the display property. So you can see here for an enum, we've got scheduled processing dishonored. And this one's doesn't have any multi-word enums, but basically you add the thing that you want to return or you want to parse when you want them to give it to you. And then use a little handy thing called getDisplayName. There's a blog post on how that works, but basically that'll grab that display header for you and parse it automatically on the way in and render it automatically on the way out. So we've got some properties. We're matching things here. And one of the most important parts about this is the projection stuff. Who here has used projections by that name? I guess maybe you've used it accidentally, but who's used projections before? OK, it's probably a quarter of the room. Projections are really, really cool. Basically, what they let you do is represent what you want to transform. You're just mapping one class to a different class. And if you've used AutoMapper, it's kind of automatic, actually, which is fantastic. But here's the manual way of doing it. We're just mapping one class to another. But we're doing it in such a way that it's not executed in real time. Instead, we're describing how we would match one thing to the other. And the power of that is that you can infinitely nest these projections. So one DTO can have a different DTO that it nests, and then that one can project a different one. And you can project collections or single properties. And when you pass this all to a link statement or an EF, an entity framework query, it's going to actually figure out what you're asking for and write a select statement that has just the fields you've asked for. Okay? So rather than going and getting all the tables, bringing it back, and then projecting it, it sends it and it translates it down into SQL, which is fantastic. So you've got basic ones like this. ID in my response is equal to the display ID on my entity. And then you've got more complex ones. And yeah, it's real word code when you see stuff like this. But basically, yeah, so you can transform. This is a little bit hacky, but basically you can transfer certain properties. We get a status out and set it as the status. Some interesting ones here are this line. The payer property is then just from entity for something else. So it's using a nested projection. And the attempts is using another projection as well. So for single elements, you can use from entity. And for collections, you can pass the projection into a select statement, and it will do it for you. So yeah, projections are really cool. You should definitely. I've got a blog post on this, on how literally exactly it works. You can dive into the AutoMapper code as well to see it, but it's a really good idea to be using projections. And yes, beautiful. OK, so we've kind of, excuse me, we've looked at the controller. OK, we've got our payment endpoint. We have a post method to save the payment. It's pretty anemic. All it does is pass down into the service layer. Let's go dive into the service layer and take a look at what that looks like. So what we have here are a few interesting things. The service endpoint receives an options class. I put my water. The service endpoint receives an options class. That options class then is validated, and you can see that on line 178. Pretty much every options DTO has that validator inside it. So we validate first, and we check if the service layer DTO is correct. Now, what this lets you do is, rather than checking properties on the controller level, so websites that hit you will get the feedback. If you bring it down to the service layer, anything that's hitting your service layer can provide that validation feedback. So if you've got an IoT device or a console app or anything else that needs to use your service layer, it gets the same validation that the API and websites do. So we check that the validation is OK. We return the error messages if it's not. Something really important to look at here is probably the service response. So the service response class is a predictable way of always traversing the layers of your services and having success notifications and error messages bubbled up properly. Okay, so rather than using exceptions, which I don't like doing, I don't mind that it's a bit slow. I just find it a bit awkward to use. Instead, I'll have a service response and a service responsive T. The service response holds things such as a list of the error messages, and I use the validation failure message everywhere. So if you're using Fluent Validation, you can just copy the array of error messages and dump it straight in the service response. If you have your own failures, you can just go new validation failure and add your own. Successful is just if there's any error messages, so you don't have to keep setting successful true everywhere. And then, if that particular service call you're making needs to return data, you've got service responsive T to return that data. And this is a fantastic way to infinitely nest services if you need to. I wouldn't do it too far down, but one service can call another, and errors will be bubbled up correctly. And even there's like a created service response as well, so you can include things like ID. So service response, you'll see every method in the services layer has a service response. And then we'll come down and we'll do a few things. Something that's important and might trap people out is that you've got to validate that the user that's calling this is the correct thing. So for me, it's the sub-merchant that gets passed in. That's the user. Always validate your users. And a second interesting thing you might see around the place is this concept of display ID. Okay? And so rather than exposing the actual primary keys of everything around the place, whenever you see an entity or any kind of object get pumped down to the user, it's always going to be a string like this. So it's got a little prefix at the front to let me know what type of entity it is, and it's got a random string. Okay, and all the URLs, if you ever navigate anywhere, up the top here is going to be that payer ID or that entity. And that's just, it's non-sequential. It's to stop people just going, oh, I'm user 2, am I? Let's try user 3. Okay, it stops people doing that, especially when you need to expose some of these anonymously as well. You need to get payers to go land on the page. They don't use their system, but they need to use that. So that helps as well. So I've got the display ID for every entity that's public, and you'll see that in a minute as well. And I mean, most of this is fairly simple. We're just updating a payer. Pull it out of the database. There's a bit more business logic in here, but I'm not going to subject you to that. We'll jump straight down to the create one. So creating a payment, I've got a shortcode service, and here's actually a really important tidbit. Who's using math.random to generate random stuff in their projects? Okay, a few of you. Who's aware that it's not thread safe? Yeah, exactly. So one important tidbit, and I'll just share this with everyone because it's super important. Random is not safe to use. As soon as you do any kind of load testing, you'll find out that, oh shit, all of my payers that I've just created have the same exact random string as their ID. So what you have to do then is kind of pull out random, and I'll just show you the random service because I think it's important. I'll run this. I'll post this code later in particular, actually. I think I've got a blog post on it. But basically, you need to take care of a few collision points because the random object uses like the current tick, the current time, basically, to decide its seed. But If you have multiple threads running at the same time, it will break each other. If you have multiple instances happening to be running at the same time, they will collide. So you need a truly unique seed for every random. And one of the ways that was suggested to me is take a look at basically the machine name or the Azure environment name, tag that with the current managed thread ID, tag that with the current time, and then use this thread-safe interlocked increment to make sure that each seed for each instance of the random service on the thread, in the process, sorry, is unique. I'll post this later because it's difficult to digest at the moment, but you just need to be aware that random isn't safe, and if you're generating random strings, load test is the easiest way to find out that you've got collisions. So I'm generating IDs, generating this kind of stuff. We throw it straight into EF. Who's using structured logging? Any kind of structured logging? Beautiful. Who's using Serilog and Seek? You beauty. It's a truly fantastic tool. I highly suggest you go check it out if you haven't already. For anything that goes wrong, you can just jump into your local instance of it. I can't imagine coding without this kind of stuff now. I can just see what's going on, and I've created some test payers, and I've got the the data that I pushed in. I can see how long everything takes, and then I can go, what's the the mean of the elapsed time or something like that, and do calculations like this. And obviously it's not going to work now, but structured logging is fantastic. You can see objects that are in the database. You can log all the things that come in and out of the service layer. Fantastic bit of kit. Highly recommend. And yeah, basically, so that's the service layer. Let me just check I haven't missed anything. Validation. Exposing error messages is important, I guess, as well. Be wary of what gets bubbled up through the service layer. So if you've got validation messages, you can just put them all the way back up. But anything you put in the service response, consider that it will be viewed by the user. Okay? Don't put internal dev system bits into your validation messages because, they assume they get bubbled, and kind of separate them out from your system logging. Use the system logging, so your logger, to make the private bits, and then use the validation to surface what happened. We've gone through random service, not throwing that kind of stuff. Beautiful. All right. So that's basically the way I do APIs. Just at this point, is there any questions about that API structure or anything like that? Anything I've missed? It's very kind of straightforward. What we're going to do, perfect. What we're going to do is jump into identity service stuff now. So pretty much, let me start out by taking a look at the, go away. Taking a look at the solution architecture. So what I have at the moment is an API layer, an ASP.NET MVC Core API layer. I have an ASP.NET MVC Core Authentication website, and that's where I'm going to be putting identity server. That's auth here. I've got a few things that we've kind of touched on. Data is the entity framework implementation stuff. Domain is where I hold all my entities and DTOs and models and classes and stuff like that. There's a few other unimportant things until we get down to web, really services. I've got all my services in the service layer. Again, talking to Jimmy about this vertical architecture stuff, it's a good idea to structure your services in a way that's thinking about functionality and not about entity. But I've got a bit of a mishmash of both. And then finally, web. Now, web's interesting. Web's the portal we were looking at before. And it is an ASP.NET Core MVC website, but all it does is spin up an Angular website as well. So it's an Angular front end, and basically that Angular front end is authenticated by the auth website, and then it talks to the API. And so what we're going to do now is just jump into the auth. Oh, if I don't screw myself up here. Okay. So the goal is we have got our API, and we've taken a look at the payment endpoint. We've got an Angular website. What we want to do now is let our developers go and use our API. Okay? And the thing that we need to start with is, all right, how do we validate who's who? And so one thing you'll see in a lot of products is they'll generate you a bunch of keys. Now, we'll focus on the development keys here. I've generated a merchant ID for each merchant or user in my system. I've got a secret key, and I've got a publishable key. Okay, so you would use your merchant ID and your secret key to talk server to server. Okay, that's how you prove who you are. And I use the publishable key to put on as really just an identifier onto anything that's public. So that publishable key you can throw onto a script tag on your website just to pop up your little face. It's embeddable, it's shareable, it's just an identifier. But the secret key is secret. Do not share that. And what we'll do with the secret key is take a look at our authentication server. So what I want to do is kind of start off, I guess one of the questions here is who's using ASP.NET Identity, just the straight username, password, storage facility with .NET Core? Only a few of you. OK, so one of the things I'll start off then is by just taking a look at some familiar code in the startup class of our .NET Core. Everyone's familiar with .NET Core? Who isn't, I guess, is the best way to do this. A couple at the front? OK, cool. We're just setting up some services at the moment, so it shouldn't be anything too strange, hopefully. So I'm going to skip through a bunch of this code. I'm going to go straight to identity. Now, this is not identity server. This is ASP.NET Identity. Its purpose is to save usernames and passwords, basically, and identify users. So you can see some stuff here where we've basically removed a lot of the password validation stuff for demos. And we're talking to Entity Framework, so we're just connecting Entity Frameworks, identity straight to Entity Framework, so it knows what tables to store everything in. And we're adding the default token providers so it can generate some data for us. We add MVC, and then there's nothing really too strange about this particular part here. Oh, actually, one tidbit. If you're running localhost locally, it's a good idea to pull out the SSL port and pass it to MVC, though this is going to change in 2.2, I think, 2.1, where everything's HTTPS by default. OK, so we've taken a look. Yeah, it's a good idea. We've taken a look at identity. What I want to do, just for context, is also show you the user classes and how I'm storing those keys that I showed you before. So taking a look at a user for me, if you've used ASP.NET Identity, the way that it's all automatically hooked up is by inheriting from this identity user. Okay? As long as you inherit from this, the user and all its properties will be saved to the database correctly. And whenever a user logs in, you'll get all that information back automatically. The extra properties I've chosen to add to my user is the concept of a merchant. This is like the idea of like a company or an organization or a group or something like that. So each merchant can have several users. They don't at the moment, but that's kind of the idea. And if we take a look at a merchant, we'll see some familiar properties when we get down to it. We've got our test secret key, our live secret key, and our test publishable keys and live publishable keys. These are just auto-generated on creation, and you can rotate them if you want. But these are just properties stored against the merchant. Okay? Nothing special, just some strings. And basically from there, we've got our strings, and I guess the interesting thing here is that when it comes to standard logins, so the website, the MVC website case of, OK, I want to identify a user. We're using identity. We just go and plug in our username and password, and it redirects us to the website, and we're logged in. Okay? So that's how we do ASP.NET MVC websites. What we're interested now is saying, right, how do we prove who the user is logged in as, and how do we protect our API using bearer authentication and identity server? So to do that, what we are going to do is take a look at it from I'll just bump up the text size as well. We're going to take a look at this from the user's perspective. Okay, so just as important as building the API protection is building an easy way for your users to connect to your API. And so SDK creation could be a whole talk in itself, but what I'm going to do is just show you a couple of interesting parts about this. And I'll just double check what we want to get into. Yeah. So let's take a look at the payments controller, I guess. I have an SDK with like a web sample. And so what we're looking at here is an example of how a customer would use my SDK to connect to the product. And it should be as easy as this. We go, OK, for whatever particular endpoint we want to hit, we'll go to payment. So get API, and you can see what endpoints we have when it loads up. It's probably a bit small, but there's the different endpoints we have. We're choosing payment, and we're going to go execute real time. So there's a few important parts here. Let's dig into get API first. And this is going to get a bit mind-bending, but get API is just getting an instance of our SDK for you, basically. And this is going to handle the storage of tokens and going back and forth. So what we want to do is return a new API given our merchant ID and our secret key that I showed you in the portal just before. Okay, there's a few other interesting properties. Probably isLive is the only other one that's interesting. It's whether or not you want this to hit the test system or the production system, excuse me. But if we delve into this pinch API, there's a few kind of interesting bits. But basically, there's an HTTP client factory as well. In .NET Core 2.1, I think it is, they've actually solved the HTTP client problems that we've had recently. And the way that you handle HTTP clients. But really all we're doing is setting some properties, including our keys. I'm actually going to jump back out. And I'm going to show you where the actual stuff happens. OK, so given an instance of our SDK, we want to hit a particular endpoint. And you'll start to see a pattern as we dive down into this particular code. Execute real time is basically just making a post HTTP request to payments/realtime, given some data. Okay, and the data that we want back is payment detailed, and the data that we were given is real-time payment save options. If we and you'll see API response, which is very similar to the service response in our service layer. Kind of same idea. It lets you bubble up errors. If you dig into the post HTTP method, and I'm going to go to this guy. You'll see that this one basically abstracts things for us. It's accepting any URL and any object as data, and it's going and it's creating a Lambda function here that is building up our request. So you can see we're going basically Lambda, and we're building up a new HTTP request message. In this case, it's a post given the base URI and the URL we want to hit, and we're accepting some JSON body data. Now, and you'll see that the other posts are the same and get and stuff like that, and there's stuff in there for files. They all hit this send HTTP method, which if we go to this guy, what this does is it actually requests an instance of the message. So line 90, it requests, it executes that function, that Lambda we passed it, to pull out the request that we're going to make. It goes ahead and it sets the authentication header, and in our case, that's the bearer authentication. We can dive into that as well. Let's get deep. Let's get real deep. The way it does this is it asks to get an access token, and this part we'll go look at the end. But assume that we can get a token. It adds that as a JWT auth header, which is basically just bearer, and we'll dive even deeper, which is just bearer, space, and then token. And that's on the authorization header, and that's set there. So we've got our token, we've added it there. We'll jump back out. It adds some other things, but we've set the auth header back in our send HTTP. What it's going to do is it's going to send that request. It's going to check if that request was unauthorized. If it was unauthorized, we have an automatic retry built in. What we'll do is we'll request a new instance of that HTTP message, because you can't reuse them. So that's why we had the Lambda there, so we can keep getting as many of those as we need. We'll reset the auth header, this time with renew to true. So it's not going to use the cached token that we have in memory. It's going to go and ask for a new one. And this time it will run the request. And if that fails with unauthorized, then we give up. We only have a one-hit unauthorized test there. But basically, that is how it has unauthorized retry, and it's how it gets the token and puts it, or rather, it's how it sets the header. What we're interested in now is how do we get that token? So, and I apologize for jumping around a bit here, but basically, up in our instance of the SDK, we have a method that understands how to get the token. So we'll just go down to the bottom here, and it's called getAccessToken. Very, very descriptive. So basically, if we have an access token in memory already, it'll just return that. If we set the renew flag to true, then it's going to automatically, well, then it's going to go and request a new token, an access token. There are two ways that you can get an access token. I'm going to be looking at the secret key way. And you'll see here that we've got the client ID and the secret key. This is our merchant ID and secret key. We can use these two pieces of information to request an access token. Ignore the other one for now. So, whoops. Access token from secret key. There we go. OK, now we're into it. So what we're doing here is spinning up a new HTTP client. We're setting our auth headers for our this request to basic authentication. Okay? And all this is doing is it's setting our username as merchant ID, and it's setting our password as secret key, wrapping that up into a basic authentication header, and sending that off to the token endpoint. This is identity server's token endpoint. We set a few parameters that we just need to set. This is in the documentation, so don't worry about remembering it. And then we hit connect/token. We hit connect/token, given that information, and then in the response that comes back is our access token. So basic authentication to retrieve an access token, and then in that access token, we can then add that to our API calls, and then that's how the bearer authentication is completed. So this is kind of what it looks like from the user's side, okay? And the good thing about having an SDK, again, is if we come back to the payments controller, they don't have to care. They just go, hey, get me an API. It's got this secret key and this merchant ID. Okay? It's really easy for the user, even though it's quite complex for you to build. And then one thing you may not know is that when we hit any endpoint, or when we even load up the site, you can actually get access to this token. I mean, I'm publishing it, so you can see it. And inside it, you can go to a website called JWT.io. And what this will let you do is it'll let you read the information, and I'll make this bigger. It'll let you read the information that's contained in the token. Okay? So I've got things such as, and we'll just come up a little bit here, and you can even hover over it and it'll tell you what it's about. So NBF is not valid before expiration date, the issuer, who created the token, and in that case it's my local identity server, who's the audience, that's the API, who's the client, in this case it's my portal, Pinch Web, the sub is the username, so the logged in user, and that's just the GUID from ASP.NET Identity. I've got a couple of things in here like submerchant ID 1 and 2. That's just so I don't have to go looking it up in the database every single time. Saves me database calls. We've got the merchant ID, and we've got the scopes that it's allowed to get. And you'll notice here, one of them is merchant API keys. Just keep your eye on that one. But yeah, so that's kind of what it looks like from the user's point of view. What we're going to do now is show you how to get Identity Server installed into your authentication project. Now, the first thing you want to do is take a look at the quick starts. I wonder if I've got them in my, yeah. There are some great sample documentation for Identity Server 4. The one I specifically recommend you take a look at is the combined ASP.NET Identity and Entity Framework Storage quick start. This is, you can clone this repository, and you can take a look at how everything works and how it's all hooked together. It's a really, really good place to start. What I'm going to do now is walk you through that anyway and what I've got. So let's take a look at that. So what we're doing now is we're jumping into our auth project. Now, as you remember, it's an ASP.NET Identity ASP.NET MVC website. Okay, standard website. We've added ASP.NET Identity to save our usernames and passwords. That's how we know who's who. And what we're doing is now adding Identity Server as a way of generating tokens based on that information. So you'll want to jump in and you'll want to add Identity Server NuGet package. This is the version I'm on right now. There's a couple of helpers here. You've got Entity Framework and ASP.NET Identity. This lets you connect into Entity Framework and ASP.NET Identity, obviously. And it's super, super handy. What we're going to look at after that is SDK. Is the startup class. So how do we hook all this up? OK, so we looked before at identity and how that was wired up. What we're going to do now is take a look at some of the identity server stuff. I've got reCAPTCHA there as well. Now, one of the important things you need to consider is that the way these tokens are generated is that they're signed by a certificate as well. So if we come out into our jwt.io, if we change literally anything in this token, the whole thing falls over, OK? So the server and the clients can use the public key to confirm that the token has not been tampered with, OK? And it's all hashed and stuff like that. So you can't alter the data that sits in these tokens. And the way it does that is with a certificate. If you're using Azure, you need to be careful of the way that certificates are stored. Okay, so they're stored in the current user, or the my store in the current user. But basically, all I'm doing here is finding the certificate by its thumbprint from the registry, and then passing that down into the identity server options. So what we've got here is the configuration for identity server itself. I'm changing a couple of the login and logout bits. I'm adding the signing cert here. You can use a developer signing cert, but I would suggest making a cert up front. It's probably better. The way I'm doing the next part is in memory. So now that we've got kind of a user, like we have users in the database, we have our API, we need to explain to Identity Server what we're protecting. Okay? And we do that in a couple of ways. We need to set up the API resources and the identity resources. So I'm actually just going to jump in here, and we'll take a look at the APIs first. All right, so API. We just need to give it a name, and it's just like, a name and a scope, pretty much. We can say, we can give it a secret so that we can prove that later on that the API is the API that we're talking to. We can include some claims for that particular API or require some claims. And we've got this thing called scopes. Now, scopes are a way of kind of segmenting up your API. Typically, you'll just have one scope for your API, and I've just got API 1. My whole API is called API 1. The only scope it really needs is API 1. But I've also got this thing here, merchant API keys. Now, I'm just saying that this is a particular scope that you can request, and that it exists as a concept. So keep that in mind as well. But all we're really doing here is identifying that the API exists and describing it. The next thing we need to do is describe the identity resources. So not only the endpoints that we want to protect, but also the data that we want to protect. So things like the OpenID, the username, the profile, name and address and such, emails. And I've also got a custom identity resource that I want to protect, and that's information about my merchant. So I've got things in here such as their IDs, their keys, their name and stuff like that. This is information that people can request from the API, and that I can allow them to read if I want to. So we're just describing. I've also got roles in there. But I'm just describing information I want to protect. So I've described the API and the information. Basically, we'll just jump down here. There's an operational store. So if you want to use Identity Server with NDC Framework, you can. It's very easy. When it needs to generate tokens and remember refresh tokens and all the other stuff it needs to do, it puts it in the operational store. I'm just dumping this into a SQL server. This is the same code that we would normally use to set up a SQL server context up higher with some migrations as well. And finally, we have the add ASP.NET identity as well, and we just need to point it at the user table, basically, just so that identity server knows where the users are kept. All right, let's just triple check we've got everything. Oh, that's a good point, actually. And you'll notice when I logged in, there's a login screen and account registration and stuff like that. The good thing about Identity Server 4, if you've used Identity Server 3, is that the views and the controllers for the authentication, like login and register and all that kind of stuff, they're just standard MVC views and controllers. You can edit them, you can change them, it's all fine. It's all part of the project. It's just a standard MVC project. Whereas in 3, it was kind of built into the NuGet package, and you couldn't change it very easily. So that's another thing to remember. But let's see, we've taken a look at that. Yeah, client store. OK, cool. So we've identified what we want to protect. The next thing we need to do is identify who is allowed access to our resources. And we do that with a client store. And what this does is basically describe the system, not necessarily the user, but the system that's allowed to access our stuff. So if we jump into, I guess, a merchant client would be the best one to start off with. Let's have a look at that. OK, so all it wants back is a client. And when you submit your merchant ID and your secret key to me, and I prove that you are who you are, I do it using these. So I get the merchant ID comes in, and I go, OK, great. I'm going to go look up the merchant in the database, and I'll give it back the company name. I'll say they're enabled. Here's their ID. They have to use their merchant ID and secret key to access this, like to generate a token. That's how they have to do it. And here are the scopes they're allowed to access. So a typical third-party developer can only access these resources. And you'll notice an absence of the merchant API keys bit here. It's on purpose. Here are the claims I want to add to their token, and here's the token types I want to give them. And so really, we're just reaching into the database, and we're saying, right, here's what that client looks like. If we compare that to a MVC client, so this is Pinch Web. This is when you're using my portal. The client you're going to get back is hard-coded, so you'll see it's enabled, Pinch Web. It has to live on this URI. I don't need consent. So once you've authenticated with my portal, it can do whatever it wants. It doesn't have to ask. Some other interesting things are probably the secrets. So ignore that. At least you can't see all of it. This is how you prove. This is how the portal proves it is who it is. You can only be redirected back to a specific URL. And if you have a look at the allowed scopes, this is the important part. It's got merchant API keys. So my portal can request this specific information. Cool, yeah. And basically, that's the setup that you need to do. So we'll just jump back up into startup, all the way back up. Here we go. So we've now identified the users, they validated themselves. We've got our own portal. That's all of the configuration you need to get the basics done, really. This is why the Microsoft making the integration and making it easy is such a good thing, because it skips a lot of this stuff. But once you've got that all wired up, down the bottom, use Identity Server. Just plonk it into your pipeline, just above where you want to protect. And once you've done that, we can start to look at the API. I've got about 6 minutes left, so let's just quickly recap. We've got our users in our database. We've got our token server that knows how to look into that database, knows how to identify people. It knows what it's protecting. It knows what information it's protecting. Now, it can generate these tokens. And we've seen from the user side how we can use these tokens to send it to the API. What we're going to do now is look at how we protect the API. And this is the beauty of the whole thing, because it's actually relatively simple. The first thing you'll need on your API project, so we're flicking over to our API project, is to use something like identity server.access token validation. Okay, this is going to build in the token validation into your system. And if we take a look at startup, we'll just jump straight down to add authentication. So there's only a few things you need to provide. You need to provide the authority. This is just the URL for your identity server, okay, where the token server lives. We require HTTPS. We say who we are, API 1. We're proving who we are by using the secret here. And that's really all you need to do. Because once you jump over to your payment controller, and this is what we kind of looked at before when we were describing the API. If you come up the top, all I'm doing is using authorize, okay? The same authorize tag you'd use in a standard MVC site. And this hooks into the bearer authentication, and it'll let anyone with a valid token hit this endpoint. But even better than that is if we go over to something like the merchant's controller, okay? So we have the same authorized thing at the top here. But if we come down to the API keys section, okay, we've got an authorized policy, and it suggests that we need merchant API keys to go and fetch the keys. And the way we set that up, again, is just in startup, just above our authentication code. We'll come up here, and we've got add authorization. Okay, and this is where we can add some authorization policies. If you look at the merchant API keys policy I've got here, the only thing it needs is a scope of merchant API keys. And if you remember in our client store, the only scopes you're allowed to request, or the only person that was allowed to request that scope was the portal. And so this is how you can lock down systems, not just users, into what they need to use. And as a really quick heads up, one of the greatest things that this lets you do in your SDK, one of the greatest things that this lets you do is it then lets you not only authenticate, your user accounts, okay, so my portal can log in Pinch users, and Pinch users can use my portal. If you build something, so I've got the Brendan website, the Brendan website can then also validate and use Pinch users using this connect functionality. And the beauty about this is the actual API code and the SDK code isn't really any different. You're just getting a different token. So when we go to payers, we can see my payer information, okay? This is the stuff that my developer account can see. This is the developer merchant account. But if I then want my product, this web sample, to let other Pinch users log in and use my product with their account, you can go ahead and connect a Pinch. And I'm actually just going to do this in a separate window. We'll use Ben test 3. No, we won't. Because we're running out of time, basically what we'll do is we'll just use the currently logged in user application. So if you've ever seen like connect to Twitter, or Facebook wants to Facebook wants to post on your behalf, or wants to access your birthday, you can use the connect functionality built into Identity Server to allow you to access that stuff. You just go yes, allow, and then you get the access token for the user who has just agreed to use your system. So Brendan's website can use Pinch user this, and then the code is identical. So you can see here where I had payer blah, blah, blah before. Now I've got NDC Sydney. All right? I've got a different user's information. And that's like a really powerful feature that Identity Server can give you as well. So we've run through like an absolutely staggering amount of code, right? You can see that this is what it takes to get even it's a relatively complex setup, right? You can read the quick start documentation to get a handle of it. But the beauty of the announcement yesterday is that basically Microsoft is going to reduce literally everything I talked about just now for one API instance and one scope to the highlighted code there. Okay? It's going to be absolutely fantastic. It's going to be built in. It's going to be generated for you. All you need to do is add the appropriate NuGet packages, and it'll figure out where to store and save everything, which I think is a fantastic thing. Now, I don't want to eat into lunch, so I'm going to go ahead and say if you've got any questions or if you need any guidance or you want to know anything about your own particular implementations of this, come up and ask me afterwards. You can find me online, Ben Who Likes Beer. Thank you very much, everyone, for sticking it out.